Let's have a look at trend of ionisation energies, and this is a trend as we go down a group. So I've picked group 1 just to have a look at, so lithium, sodium, potassium, just the start of group 1, and in terms of their electron configurations, lithium's finishes with 2s1, sodium's finishes with 3s1, and potassium's 4s1. So I've drawn 3 crude atoms there with the correct number of shells, and then we'll just pop an electron in the outside shell, and this is the electron that we'd be removing in the first ionisation energy. So what changes as we go down group 1? Well, clearly we can see as we go down the group we're introducing an additional shell for each member of the group, so we've got more shells as we go down the group, and with more shells means that we're going to get more shielding from the nucleus. You're right in thinking that as we go down the group the number of protons increases, so the nuclear charge increases, but this is outweighed by the fact that we've got more shells and more shielding. So as we go down the group, the nuclear attraction on the outer electrons decreases, and this means that ionisation energy decreases. And this will be seen in any group, so as you go down a group, ionisation energies decrease. And in group 1, because their reactivity is about losing the outside electron, as it's easier to lose the outside electron in group 1, their reactivity increases. Let's now have a look at ionisation energies and their trend across a period. So we can see set out here we've got period 3, so going through from sodium to argon. If we have a look at the electron configuration, sodium's finishes 3s1, magnesium's 3s2, aluminium's, we move into the P subshell, 3p1, silicon's 3p2, phosphorus 3p3, sulfur's 3p4, chlorine 3p5, and argon 3p6. So what do they have in common? Well, the electron that we're trying to remove in each case is from the third energy level, that third shell. So this time, as we move across the period, unlike when we were looking at the groups, this is the same shell that we're removing the electron from, which means that we will have the same, or sometimes you'll see it referred to as similar shielding. So the shells and the shielding not having a big part to play. So what is changing each time? Well, as we go from sodium through to argon, for each element the number of protons is increasing. So the nuclear charge is increasing, but we're removing an electron from the same shell. So ionisation energy, as we move across a period, will increase. And these factors will also mean that the atomic radius, because there's a greater attraction on that outer shell, the atomic radius will decrease as we go across a period.